to machine or contrast to machine, we have a human. So what is a human? So we talk sometimes about recognition and cognition, like we have some synonym of machine learning. It is called pattern recognition. Sometimes we say pattern recognition, sometimes we say machine learning. So we need finally to know what is machine learning and what is pattern recognition. So to know what is pattern recognition, we should know about what are patterns, what is recognition. To know about recognition, we need to know what is cognition as well. To know about cognition, we need to know about perception. To know about perception, we need to know about machine and the human. So we have something called the human machine. So we have something called machine perception and the human perception. Yeah, let's start with machine. What is a machine? Ahmad, what is a machine?
A machine is a computer device or a computational device that calculates.
That's enough. That's enough. In machine learning, when we say machine, means it is a computer, or more generally, it is a computer-based system. That's all. So we don't talk about mechanical or electrical machines. We just talk about computers or system-based computers. So what is a human? A human being is us, me, you, she, he, etc. What is perception? Perception is the way you notice things. How do we notice things around us? For example, we see objects surrounding us using our eyes. We say this is a visual perception. So how we can make machine perception, how we can make computers see, like in contrast to humans see using eyes, computers will see using cameras. If I connect the camera to the computer will acquire images from this camera and then processing it, understanding them, then it is visual perception by a computer. Again, we need to know about cognition and recognition, because finally I am interested in pattern recognition. What is cognition? What is recognition? So cognition is the process by which we understand and develop information and knowledge in mind. How do we understand things? How do we understand information? This is a perception. Like when your eyes see some objects, you know this object is an apple. How do you know this is an apple? You learn this object and you use to say it an apple. Okay? But what is recognition? So let me tell you simply, when you see an object or somebody for the first time and learn about its properties, its features, attributes, so we say this process is cognition. When I see the apple for the first time, I learn about its color, its shape, its general properties. So I say, this is something that I will call it apple. I will call it apple. The name is the name, does not matter the content. We don't talk about how the name related to the content. Why we call it apple is not our job. Our job is to know how do we learn it is an apple, because we learn its properties. We learn its shape, color, etc. Now, next time, when I see some new apple, I see that object has a shape similar to the apple shape. It has a color similar to apple's color. It has some XYZ properties. Then, oh, this is an apple. This process is recognition. I already know something. I already know about something. I have already seen something, but now I am seeing it again. So seeing it again, noticing it, observing it, perceiving it generally, maybe by eyes, it is seeing, by ears, it is hearing, by tongue, it is tasting, etc., etc. So this is When we notice, observe, recognize something for the next time, it is recognition. Recognize something for next time. Usually it is easy understood how to connect cognition and recognition. It can be done using the English suffix re. Usually in English, re is used to express the action for the second time, for next time. So recognition is repeating the cognition process. I already learned about something as a cognition process. Learning again about this, noticing it again, observing it again, it is a recognition, recognizing it again. Okay? So I hope this discrimination between cognition and recognition is clear for you. So cognition science is a different discipline of science. We will not study about cognition here in our course. We will study about recognition. Okay, recognition, some people say it is same as identification. Like when you have some new object or a new system, we need to know about this object or system. So we say system identification. We have information about the system, but we don't have idea of this system or this object. So we do something called identification. Identification is the process of showing, proving, or recognizing who are or what something is. So we can simply consider identification is something more general than recognition. Recognition is related to the cognition process, to the perception process, but identification related to the systems in general. These systems can be mechanical, electrical, computer-based systems, human-based systems, whatever. We can say it is identification. But when we talk about objects or humans or something like this, it is recognition, not identification. So recognition is something special from the general case, that is identification. Now we come to the more important notion. It is about learning now. We already know about machine. Now we want to know about learning. What is learning? Learning is the process of learning something. Sometimes we say computer-based learning, face-to-face learning, online learning. Learning what? Learning something, okay? We usually learn about objects. We usually learn about humans. We sometimes learn about new humans. We see them on the street or we meet them somewhere. So this, how to earn experience about new people, new things, it is a learning. Okay, so learning machine or machine learning, that I am teaching the machine. Teaching the machine what? Teaching the machine how to recognize object. Okay, so when I talk about object recognition is a process. This process is realized, implemented, executed using some machine learning algorithm. So we need learning. We need to learn the machine, allow the machine to learn how to recognize objects or how to recognize pattern. Okay, let's be clear now. I need this again when I want to distinguish between machine learning and pattern recognition. How is pattern recognition different from machine learning? So let's remember, machine learning is learning the machine to be able to recognize the object. So the action is the recognition, but the algorithm is learning algorithm. Okay, I hope that I'm not checking the chat, so I hope there are no questions. Where's the chat panel? here? There is no any question. So I don't have any questions. So I hope that everybody is following. I think now it is the time to check the attendance. The attendance is automatically done. So everybody write present. I want to take the attendance. Please, everybody write present. I will give you only 30 seconds. After that will not be considered. That means you are sleeping, not following me. Your pen, I think, is your camera is open. Maltam Hoja. Yeah, your camera. Yes.
I open because I'm present.
So everybody has written present. Okay. Can you copy this list of presents and save it in a Word file?
Sure.
Or some document, so I keep it for use later.
Chat is recorded. But we should take a snapshot because something wrong.
Okay, now I also will introduce pattern. What is a pattern? A pattern is a regular way in which something is done or something has happened. For example, I don't know if you will see, if you, I will try to write something on the board, but no, we did not get a pen. Okay, let's assume, let's imagine that something. Let's imagine pattern in this way. If all of us look to the sky, we can say a cloud, okay? A set of clouds distributed here and here and here in the sky. For example, if I picked only one piece of clouds, it looks a pattern like this is different from anything else. Sometimes we can observe some different shape of clouds, okay? This is different from surrounding and the largely distributed clouds. This is called a pattern. This is a way, a regular way in which clouds are assembling, okay? Patterns also happen in textile industry. If we pick a cloth piece, we look to the appearance of this piece. For example, my T-shirt, if I zoom it, you will see some small dots. These dots that are distributed in your cloth or on your T-shirt, it is a pattern or a set of patterns. Something regularly happen, different from the noise. Inside the noise, we have something happening, okay? If we look to a tree, for example, we can see a lot of leaves, okay? Every leaf is a pattern. It has a certain shape and repeated on the branches. So this leaf is a pattern, okay? We can imagine like if I have a set of random lines on the board, assume here, on the board now, you can see a lot of writings, okay? Random writings, some lines, some small circles, some. But here I can recognize a rectangle. Here I can recognize a square. This is a pattern. All dot are come together to draw a line. Line is a pattern, okay? Also, another more example from our life about our faces, okay? Now you look to the screen, you see my face, you see my head, you see my shoulders, okay? So you can recognize some two rectangles here. There are my glasses. You can recognize some black spots here. It is my hair. This spot represents my hair. Okay? You can recognize some curve here. It is my nose. You can recognize two curves, one curvature toward down, one up. These are my lips. Every one of these is a pattern. Okay? So even eyes are pattern, nose is a pattern, mouth, lips are patterns. Complete set, which includes eyes, nose, mouth, all of them is a one pattern. That is my face. Okay? So sometimes we talk about face recognition. This is a pattern recognition problem. Sometimes we talk about eyes recognition, like I want to detect where are the eyes in this image, for example. So this is also pattern recognition. Okay? Sometimes we say pattern is the opposite of chaos. Chaos means something happened randomly. When something does not happen randomly, it forms a pattern. It constitutes a pattern. Okay? We may say some things, not something, many things happen in the same way. When small dots are come close to each other, we have a line. So this line is a pattern of points or of dots. Okay? Now I want to come to a conclusion about what is pattern recognition and what is machine learning. Pattern recognition is an action, is an engineering problem. So it is like something classification. I have a decision. This is my face. No, this is the face of somebody else. Is this person Ahmad? No, this is not Ahmad. Is this person Ismail? No, he is not Ismail. Yes, he is Ismail. No, she is something. No, yes, no, yes. Take decisions. This process is pattern recognition. Deciding about something belong to some set. Okay, but how it is done? When I say pattern recognition, usually talk about machines that do pattern recognition, about pattern recognition using computers. So how computers know? How do computers know to do it? We have learned it. How we have learned the machine? Using machine learning. So machine learning is something that computers understand. What do computers understand? Computers understand only programs. So machine learning is the programs. Computer programs are written using algorithms to allow the machine to work like a human. Because recognition, learning, perception already started by a human. And we are in artificial intelligence generally, we mimic human abilities. We try to give computers human capabilities. Okay? Now, the difference between machine learning and pattern recognition is clear. If it is not clear, we can more specific, be more specific about it. Let's say pattern recognition is a set of algorithms, systems that make classification of data, make classification of noise, while machine learning is a science, is programs is algorithms learn how to do. So pattern recognition is doing the recognition. Machine learning is teaching the computers how to do recognition. Okay, so pattern recognition is recognizing object. Machine learning is teaching computers how to recognize objects. Okay, I hope this is clear. I would never expect a more clear statement about machine learning and pattern recognition. Now I will try to show you some applications. So applications of pattern recognition, for example, sensory applications. Sensory application, understanding images. So we call it vision. We have a camera connected to a computer, so this is a vision. We have a microphone connected to a computer. We speak to the microphone. Our voice is stored in the computer and processed by the computer, so it is a speak understanding. Okay, we have also a kind of textual data. Textual data means I do processing on the text itself. I already have a text, for example, a text written by handwriting. We need computer to understand this. Okay, sometimes I have a lot of information. You say data from bank, account information. We have information about account holders, etc., etc. So we need to get certain information about this account. So we need to apply data mining. So such applications are called data mining. Sometimes we have also now application about genome, like genome engineering. In genome engineering, we do processing on genomes, genome sequence. Genome sequence are like protein sequence, and also it is just like RNA and DNA acids sequences. So we need to do some processing about it, recognizing a certain segment of sequences. Okay, this is also application of data machine learning and pattern recognition. Also, I can see here in this table a lot of applications. This application like varies from industrial application, maybe health science application, industrial application like manufacturing. Also, it can security application like fingerprint identification, online handwriting identification. These all are kind of security applications. Please read this table. Read this table slowly and try to understand or guess. Do you have idea about any of these applications? If not, you just type me a question into the Google Classroom, okay? Here, I can explain some of them. For example, this, the most left image, show me a handwritten text. So we need to recognize who is the writer. Sometimes we need to understand the writing itself, as in this. Sometimes I have a certain characters, and I need to understand what are these characters. For example, all characters in this image represent the A letter in English. Okay, so how can we teach the computer that all these characters represent the A letter? This is a machine learning and pattern recognition application. Also, we have the fingerprint recognition example. See, we can recognize here several types of fingerprints. No certain model, no certain pattern. Look, there are a lot of several of patterns. Every pattern is different from the another pattern. Our fingerprints are not same, but also different patterns are there. More examples in biometric recognition. So biometric can vary from fingerprint recognition, face recognition, iris recognition, voice recognition, hand recognition, signature recognition, face model, face X-ray model. These, I guess, are teeth samples, teeth X-ray, and several applications. In real life, we have so many applications, like in the visual domain, in the biometric domain. When we say biometric, means patterns related to life people, like humans, animals, etc. It has applications in biochemistry and medicine. For example, here we have two images, one for a safe tissues and one for cancer attacked tissues. So we can teach our computer how to recognize between these two images. Here we have a geographical application, like we try matching or recognizing satellite images. Is this image match? Does this image match this image? If I am able to say yes or no, I am doing a recognition. You can see the two images are taken in different time moments. So appearance is different in the first image from the second image. Another example is license plate recognition. You can see that this in the image, we have the license model, the license plate model of in the US. So in Turkey, we have something different. In Europe countries, we have different patterns. So we can design a system that recognizes every pattern, and we recognize also the information written on this pattern, the numbers and characters. So here we have numbers, we have characters, we have some drawings. So we need to recognize all these things to be able to decide what is this card and it belongs to what. Finally, before going, I will just introduce to you one example, and we will stop here. Then I will continue explaining them in another class using video recorded, and I may upload some videos for you to the YouTube and give you the links to the Google Classroom, or maybe next week we can continue the same discussion. Here in this image, you can see one or two fish. Okay, assume I have a sorting fish problem. Like we have a machine that will sort out the fish according to types. Assume, to simplify the problem, I have two types of fish. One type is called sea bass, one type is called salmon. Okay, so these two type of fish are different. How I can recognize one type? Like if I am given a fish sample, how can I say this is from type sea bass or this is from type salmon? I personally have no idea about fish. I don't know. I cannot decide. Okay, but I have one friend. He is working in somewhere to the coast, you say in Mersin, and they have a good knowledge about fish. So he will tell me, Hafiz, look, salmon fish is a short fish with light color. Sea bass is a long fish with dark color. Oh, nice. So I can easily say this is salmon and this is sea bass fish. It is easy to recognize. But if I want to program the machine, I want to write a computer programs, enable this machine how to recognize this is salmon, this is sea bass. Okay, this is a real example and also good theoretical example to study as a case study. Okay, so now someone will tell I will use the length of the fish and the color to recognize it. I say, okay, but maybe they are not enough. If they are enough to this example, maybe they are not enough to another example. So sometimes we will see long salmon fish. So, I will say, oh, this is a long fish, this is a sea bass, but it is salmon. I should not do this mistake. How can I avoid? Because there are even generally sea bass fish is long, salmon fish is short, but there are some salmon fish that are long enough to be similar to sea bass. Similarly, we have generally sea bass fish are dark, but sometimes we have a lighter color fish that is similar to salmon. So sometimes, what is the conclusion here? Sometimes selecting certain features like color or length, sometimes is enough, sometimes is not enough. Let me explain to you. I still have 5 minutes. Here, let's take the black line. This black line is the histogram of salmon fish. It is the length. What do we mean by histogram? I don't know if you studied image processing or not. What I mean by histogram, it is the number of fish. How many fish? For example, here, the horizontal line is the length. Okay. For example, at length 5, how many fish, how many salmon fish carry the length 5? This is the number. You say 16. How many fish with long 4? This 18. How many fish with length 8? It is 22. But this should be among a certain number, like say we have taken a container that have 100 fish. So I measure by hand what is the length of every fish. And then how many fish with length equal to 1? I will say 6. How many fish with length equal to 3? I will say 8. How many fish is equal to 7? I will say 12, etc., etc. Okay, then for all fish, I take the measurement and draw this line. We call this line is the histogram. It represents how many fish, count of fish that carry certain value of length, for example. Here I take the length. Okay, so this is the curve. This curve is called the histogram. Sometimes statistically and probability theory, we call it probability density function. Probability density function. Why probability density function? Assume the total number is 100. I think it is not 100, but assume it is 100 as an example. If I pick randomly one fish from this container, what is the probability that this fish has the length 6? Okay, I just go directly to the curve. I take the length value 6, project it to the curve. The curve value is 12. So I say it is 12 out of 100. 12 out of 100. It is 12%. The probability that a randomly picked fish that carry the length 6, the probability is 12%, 0.12, because the total number is 100. I divided the number of every value on the total number, that is 100. Clear? Meltem, clear? Ahmad? Okay. So anybody has a question about how to draw this histogram? No. No questions. Okay. So you can see what I want to conclude here, that at this point, like for a small length, let's say short fish, salmon fishes are more short than sea bass. Sea bass are represented in the red color. Here, sea bass are more long than salmon. Okay, but I cannot make this as a tool to make a decision. If I say every fish longer than 12 is sea bass, every fish smaller than 12 or 11 is salmon. Look here at value 15, 18, 20, 25. There are a lot of salmon fish with long fish, like with long body. For example, we have so many fish with length equal to 15, 20, 25. These fish, if I decide to discriminate or recognize using the length, this fish will be recognized as sea bass, but in fact, they are salmon. So taking one dimension, one property is not enough. We may need to take more than one property. So taking more than one property, I will talk to you about it in a next session. Okay? For now, let me say for you, see you next week, but I will try to record the videos and upload them to you on YouTube and share the link with you. Okay? Any question? Any question?
Thank you, Doctor.
If there is no question, you can leave the session. Please keep following the Google Classroom for any announcement. So surprisingly, I sent a question to the Google Classroom and nobody answered it.
Yes, it's very interesting. And should I create a new Google Classroom for Python?
No, you will use same classroom. You don't need.
Which is the question?